you visualize in your mind that thing being folded up to form a box. The X itself, this little X, is going to be representing the height. So I got that, and that. Length, width, and height. Does it make sense? The X right there will be acting as the height as you fold up the sides. Now the volume says, I mean, you guys said, Professor, just multiply length times width times height. No problem. This is my length. This is my width. This is my height. And Jonathan, all that's in terms of X.
Yep.
Okay. Now, I'm not going to ask you to multiply it out today. It might be wise to express it like this. I think it looks better like this. I'm going to put the X out front, which looks better. Then 24 subtract 2X, quantity squared. And I'm going to leave my answer like that.
That's exactly how the book put it too.
It looks better like that. I'm not going to ask you to expand it out. Make sense, guys? Length times width times height?
So the 2x comes from.
Yeah, that two, beautiful.
2.
Yeah, that 2x comes from one X over here on this corner is being cut out, another X here. So altogether I got 2X being cut out. Before I get to the box. X on each corner. Okay? Yes?
And how do people visualizing how height is
And that's the best thing to do is just when I did this little demonstration, the height, even on my little demonstration of the box here, was that little piece of the corner right there, which is the X we're talking about here. It's that little piece of the corner right there that represents the height.
If it helps, draw a dotted line between all 4 of the boxes inside.
Well, you could, that's not change if you do. Does it make sense? That little corner right there, that little corner right there is the height, which is the X, as you fold up.
I think she's just asking like, why is it X, right? Is that?
Well, X was, they didn't give you the height, so it's not known.
Yeah, okay.
Yeah.
Got it.
Okay, make sense, guys?
Yeah.
That's what we did. Jonathan, this is a function now, not f of x, it's v of x, volume, it is a function. Did they ask me to do anything with it? Or that was it?
Express the volume as a function of length X of the side of the square cut off on each corner. I think that's it.
That's it. Oh. Now, what do we usually associate with a function? Since I have one here, what do they usually ask us besides this f of x? What else could they ask me about a function that might be appropriate to answer here?
Domain and
What is this domain? I'm not worried about the range. I'm worried about what can I replace x by, since this is a real life type problem. Guys, to find the domain, look at this. To find the domain on that function, if asked. Is this 24 subtract 2x? Let's go back here. Is that 24 subtract 2x, we're talking about a length. Should that always be positive if we're talking about length? It can't be negative. Can length be 0? No. So right here, 24 subtract 2x, Professor, for this problem must represent something positive. Because we're talking about measurement. You can go ahead and solve that inequality. You have it stated. Divide by -2, reverse your symbol, x is less than 12. So there's one condition on the x. That's done. Also, this little x all by itself down here also represents a measure, it's a height. Can a height be 0? No. Can a height be negative? No. So what are you going to say here? X must be what? Greater than 0. For this little piece here. So 24 subtract 2x, I took care of that. X also must be greater than 0. Now, can anyone tell me what the complete domain of this function would be? Based on what you see here.
What is that?
Put both together.
Negative.
Integral notation.
Is it negative infinity to 12?
Nope.
No, sorry, 12. Actually, no, just.
0 to 12?
open 0, 12.
Now, there you go. 0 up to 12. That's your domain. Those are the only numbers you can use here. Or you end up with a negative answer or something strange happens with your volume. You can't have a negative volume. So that's the restraint. That's your domain of that function. You replace x only from 0 to 12. In fact, you can't even use 0. or 12, if you're asked to find the domain. Now, Jonathan,
Yeah.
read number 2, and let me see if I'm gonna do it. I'll read it to me first.
So it says the water is poured.
Ooh, mark in your paper now, that will not be on Monday's test, I gotta save that for the quiz Wednesday. I will not look at it today. I will try to stick with box forms if I can. What's the next one?
An open box.
Oh, there's another one, I'll get that one, that's okay, that's a box problem. Hang on now, read that to me.
Okay. So it says, an open box with a square base is required to have a volume of 10 cubic feet. And then it says express the amount of material used to make such a box as a function of the length x of the side of the square base.
Can you imagine, guys, if I just came in here today, that you're having an exam on Monday, you're nervous enough about the exam, and it goes all the way through 1.6, which he's reading for me now, and I did not do anything, I just said it goes through 1.6, and I'll see you Monday, and I did not show any examples. Wouldn't it be nice if I didn't work anything out for you? I just say it goes through 1.6, would you like that?
No.
No. Are you gonna get that at the universities? Yes. Yes. And their classes usually are maybe 60 minutes long. They're not 3 hours. Yeah, they just throw it out there and then you say, get it. You're gonna have one of these box forms on your test. But professor, could you work one out for me? Not today. Exam's coming up. Okay, read that one more time.
Yep.
This is last, by the way, I think this is the last application problem I will hold you responsible for.
So an open box with a square base is required to have a volume of 10 cubic feet.
Okay,
And then it says, express the amount of material used to make such a box as a function of the length x of the side of the square base.
gotcha. Basically, guys, and I'm gonna close it down with this, I'll hold you responsible only for these types Monday. You can't go wrong. He tells me I have a box. May look something like this. Connect the corners here. Yes. And, oh, this line up here. Let's say it looks something like that. Okay, got the box. Ooh. John, I got, I always do my little drawing there, I forgot the numbers now, tell me again.
So it says, open box with a square base is required to have a volume of 10 cubic feet.
I went out, so the volume of this box must be 10 cubic feet, written like this. So it must hold 10 cubic feet of water, or whatever we want to pour into it. That's the volume. Now read a little bit more to me.
Yep. So it says, express the amount of material used to make such a box as a function of the length x of the side of the square base.
Now, this one, they gave the volume to you, to begin with, not find the volume, they gave it to you, it's 10 cubic feet. They're saying, how much material would it take when I go to Home Depot and buy my material to build this box? How much must I get? They want to know how much must I get. Thank goodness, did they say the box is open? I think it said open?
Yeah, open box.
If it's open, at least I need not worry about material on top here, this is open. So they're saying now, you gotta come up with, and here it goes, gotta be very careful. I think you said it's supposed to be a square base,
Yeah.
I think, so I'm gonna go ahead and mark this as X and X to show these two should be the same length, if it's a square down there. Did they specify that the height also is the same? Did they say anything about the
No,
height?
it just says express the amount of material used to make such a box as a function of the length x of the side of the square base.
Okay, so they mentioned height. They did not say the height was also x, so I'm cautious. But h for height. By the way, guys, if they were all the same, what would this thing turn into? A cube. X, X, X. Is that true? If all these dimensions were the same number, it's a cube. They didn't mention the word cube, did they?
It says cubic feet, but no.
Oh, cubic feet, not a cube. Okay, so I don't know what that height is, guys. All I know down here is the square he gave me. Now, here we go. They're saying, please tear this box apart and see how much material you need to build this box. I'm gonna start with the base. I'm gonna shade it in. Base is down here. Now we're talking about area, not volume, the area of this box. So we got the area started out with, and I want all this in terms of x eventually. So I want a of x. Can anyone tell me what is the area? And that's a square down there, rectangle. And how do you find it? Length times width, we're talking about area. In this case, what? X times x gives me what? X squared. I'm done. That's the base. Now, if I jump up and say, hold on, professor, let's get the complete box. The top here should be the same. But did they not say the top was open?
Yes.
So I don't have to worry about it. That's one piece of the box I don't have to worry about, the top is open. Now the sides, gotta be very careful on this, I'm gonna do red here. Guys, this side of the box is also a rectangle. I think, if you look at it closely, guys, is it, that should be an X here, is this XH again? For the red? Yes or no? Okay, so length times width, X times H. In this case, X times H. X times H will give me the area, length times width. Straight across, with this side of the box, would that be another XH? Okay, so there's another XH there. No problem. Now, what do we have left? I want to worry about the top. Top's open. What other pieces? Do I have more pieces left here I'm worried about? Yes. Guys, how about the piece out front here that's staring at me? What do you think its length times width area would be there? Another XH. And I'm not going to shade it in, the one in the back, which I have not shaded, would that be another XH? For length times width. So right now, I have the area, guys, to be this. Look at this. This is x squared plus how many XHs? 4 XH. Now to finish this up, Johnson has asked me to express this area of this box in terms of only x. I have some partial credit here. What's my concern right now with what I have? I see x squared plus 4xh. They want this as a function only in terms of x. What's the issue? The h has got to go. It's got to go. Now, can someone in this clever class tell me, how can I substitute something for h, make it go? Because it can't stay there, they want everything in terms of x. Does someone see something on the board, being clever, that I can do, you can do, and come up with a substitute for h?
10 minus x squared.
Tell me again.
10 minus x squared.
Okay, just x squared?
Yeah, 10 minus x squared.
Oh, 10 minus. Oh, getting close, I thought you had it. Getting close, not quite. Oh, he's close. Okay, let's go back to that volume. How do you find the volume of a box like I did on that first one? Length times width times height. They gave it to me a 10. Expressed though is what? This times this times this.
Oh, 10 divided.
Is that x squared h, if you multiply length times width times height, that's volume. Is that x squared h that we're talking about, equal to 10.
So then ten is
Is-
equal to x, or ten over x squared.
Yeah, so exactly, I heard him
H
say
is
10
equal to
minus
10
x
over
squared.
x squared.
Is that x times h, length times width times height, that's the volume. They said it's 10 in this case. Now, if I need to substitute for h, which I do, let's find h. Divide both sides by x squared. There's h. And now, since I have it, we need it, take it down, and substitute h with it. And now rewrite my function, now it should be all in terms of x. It should be x squared plus 4x, now in place of h, we put it in red, we're replacing, substituting with 10 over x squared. Close that up. And guys, we'll clean this up a little bit here. This is x squared plus, if I clean it up, I could cancel one of these x's out. And 4 times 10 is what, 40? 40 over x, and I'll leave it like that. And we're good. We are good on that. There's the area of that box expressed only in terms of x. Wow.
So because the x squared is in the denominator, you get to take the x out of four and x squared, and it'll leave 40 over x. That's.
Yeah, right here,
how that works
if
out.
x, I can cancel one of these x's out. X into x squared.
Okay.
Yeah, just simplify it. Now, this is the problem that I'm not gonna tell you the professor's name. This is the one that he always has on his first calc test. Usually, I've heard from my former students. Also, my former students will see me and say, "Oh, professor, just had my first best friend test. I saw the box problem, professor." He usually puts this box problem on there. Guys, any concerns? On this, we have worked so hard today. We have worked so hard. No wonder my voice is leaving me.